Hello guys, welcome to Laptex. My name is Nasir and I am again with the same case study which we have left last week. The board part number is DV15CP, and the thing whatever I have done, I have demonstrated you that EC reset was having glitch, and 3.3 and 5 volt was missing. I have generated that there was unable was not coming on the pin number 18, so that is absolutely fine now. And after that, 15 volt charge pump was missing in this board, and after removing the charge pump diode, now the situation is stable on the 3.3 and 5 volt as well as 15 volt. Now I would like to show you that what is the load. This is the load where the board is stuck up. When I plug in, you see that the load is stuck up on the 0.055. So let's begin from the diagnosing from the basic, and the basic comes with the RTC, and I would like to shed some light on the some important signals, but the more depth you will get on our video classes. So if you are required to boost up your knowledge, then you must contact on the given number. This is just a demonstration of the case study for the particular model. So in this particular case study, I will only tell you that what is the reason that the laptop is not turning on. So we will start as the data sheet will suggest us to check this model. Now let's come and check from the beginning. So first of all, let's see that do we have the power sequence or anything else like that. So this is the power sequence we have got. So AC mod and the DC mod. So what is this? AC mod is for the adapter mod and DC mod is for the battery mod. Now in the battery, if you pay attention here, you will see that merely few signals, after few signals, your board should be turned on, because what does happen in the board, in the battery mod, the less power need to be consumed in order to save the power from the battery. Now if you see the AC signal, you will find out the more signals and more voltages need to be present on the board in order to turn on. So since we have this motherboard only, we don't have the battery pack, so we will check it with the AC mod. Also, if we don't check it in the AC mod, so what if the laptop turns on with the battery? The customers ultimately will be required to turn it on with the adapter. So we need to clarify that board must be turned on with the help of DC jack or with the help of DC power supply. So here that around 10 to 12 signals are required to check. So the first, as you pay attention here, RTC VCC, then our PCH RTC reset, then power SRC, the common point we will check, then LDO will be present. Now S5 enable, which we have achieved, 5 volt always we have got. So let me mark it what we are getting on this point. So we have the power SRC, we haven't checked these two signals, so we will check it first. Now power SRC we have LDO 3 volt available, we have S5, now we have 5 volt always, we have 3 volt always, we have 15 volt always. These 4 was having problem, we have repaired on this. Now the situation is going after 15 volt. So after 3 and 5 and 15, we need to check this one. 3.3 and 5 volt power, okay, we do have or not, we haven't checked as of now. We will check it, this one. Sus power DNACK, this is the acknowledgement voltage in order to stop the motherboard to go into the sleep mode. So we need to have this voltage on the board wherever it is going or it is coming from. This signal acknowledgement comes from the controller IO to acknowledge the PCH to whether stay in the S0 mode or to go into the S4 state or S3 state. PCH RSM reset, we need to check this also. Sus clock, we need to check. AC percent, we need to check. Then we will try to press the power button and then the board will turn on. So here let's begin from these things which we have left: 3 volt and 5 volt power. Okay, now let's check this. So right here, 3V underscore 5V underscore P. Okay, power. Okay, now let's check on the pin number 23 of TPS 51123. Okay, this is the TPS 51123. Now let's come and check. Now on the pin number 23 we need to check this, so let's come and check. Pay attention on the multimeter. So 6, 12, 18, 19, 20, 21, 20, 23 here. So we have 3.3 volt power good, or we say power okay, is available. Now the next point is, let's go back. In the most architecture like the Dell Vegas 6, 7 generation and 8 generation, you will notice that if you don't have power okay, the board will not turn on, just because this power okay generates RSM reset, and you will not, if you don't have RSM reset, the laptop will not turn on. So always pay attention on this power okay. We most of the time just check 3 volt and 5 volt, and we say that 3.3 and 5 volt is absolutely okay. So power button. Now let's check the power button. So PWRBTN. Let's move to power button, and this has the 10 millisecond debounce logic. And what is it? You will come to know in our video class. There we have described that what is the single debounce logic and double debounce logic, and why this is required signal, and what is the role of this power button or to be debounced. Now this is the signal which is switching on the PCH, and let's come and find out what is the number of the pin. So here we need to check it on the SIO. So this is the PCH. It is going to PCH. Now pin number IO is 95. So we cannot check it with the help of multimeter, just because it has debounce logic. So we need to check it with the help of DSO. Now, so I have turned on the board. Now see. So here you can see that 32, 32, 32 is equal to 96. This is the 95. So here we need to check on the pin number 95, that is, do we have the debounce logic or not. Let's check it. So we are not powering now. We will just inject the DC jack into the motherboard and turn off my power supply, and we will keep my probe, the negative, on the ground reference. And now let me keep 95. So you will pay attention on the DSO that when I turn on, nothing happened. Okay, now let me do one thing. Let me set it first. The setting is required. Let's set the time. We have to increase the time on 500 millisecond or 200 millisecond, 1 millisecond. Now it will run like this way. Then you can notice it. Okay, now see what does happen. Off, on. You notice it. Now let me set it on the capture mode so that you can easily understand that how does it behave. Exactly the same you have seen on the diagram. So guys, I am going to capture the signal on the debounce logic. So now I kept my probe on the 95 number, and now let me power it up. So we are not getting the debounce logic. If there is no debounce signal, whether the IO could be faulty or PCH could be faulty. So is that right? Because it must be lower down on some of the point. it must have the low edge signal on some point of time. So every point I have checked, like here, if you reduce the time, if you increase the time, check it. Unless you get it like 1 millisecond, you will get very, the last limit I have checked 500 millisecond. Now let's check it on 500 microsecond. Okay, now off it, run. Now check it. So this is 95. Now nothing, we haven't got. So it makes us clear that whether the problem is on the PCH or SIO. So must write that whether it's true or false. If you receive any board, any generation, you check this particular signal on 500 millisecond to the 500 microsecond, and you must get a debounce logic. So how can you generate this debounce logic? Next, signal. I am just demonstrating you the signals as per the requirement. Okay, now here we were, and we need to check the sus power DNACK, also PCH RSM reset. DNACK is something which will turn on, at least the board is not having display, then you need to check the signals. I will check it later on because this tells up. However, one thing is very much important here, that this particular signal must not have ground. If it is ground, then it will stop to release SLP S4, it will release SLP S3, the PCH will not work ultimately. The PCH RSM reset. Now let's check, this is the most important signal, the resume reset. Now let's check it. Best, we have to find the IO pin. So this is the IO pin, pin number 20. Now let's come and check pin number 20. Now come back, pin number 20, let's check it. Here is the pin number 20, 5, 10, 15, 20. So let me turn on the power supply. It is present and good. Now we need to check the next signal, that is sus clock. Maybe here PCH sus clock. Let's check sus clock, copy it, paste. We have to check it on the controller IO because on the PCH point I haven't seen that particular this motherboard is board view present or not. 77 number we have to check. Okay, 32 kilohertz frequency DC mod we will get on the 77 number pin. Now here you can see that 32, 64, and from here we have to check 77, 65, 70, 75, 76, 77, this one. Now remove from the run, start. Yes, absolutely we have. Now you can see that 32 kilohertz frequency DC mod is present. If I bifurcate the signal, now you can see this is 32 kilohertz frequency and DC in the DC form, and we are getting this from the PCH. This is the signal which is required to communicate with the further communication. This is required for the further communication between the PCH and your SIO chip. So we have available on the motherboard. Now the next one, let's come back. AC present. First, your charging IC will release AC in or AC OK signal, which will reach to the controller IO, and afterward the controller IO will say to PCH, yes, the adapter which is inserted is healthy and working fine. So this is the final report from the adapter to the PCH. Now you need to have 3.3 volt on this pin. So now let's come and check. It is on the pin number 112 and GPO84. Let me tell you one more important thing, that what is the important role of the GPIO, GPP All these things we will discuss in our video class, because here this is not possible, because as long as you have seen that the first part has been you have seen, that was the long video. Also this is going to be too much long, so this is not possible to describe each and everything. We have more than 300 hours video to complete the course. So if you are interested in to learn the each and everything, that what is the communications, internal logic of the charging IC, internal logic of the 3.3 and 5 volt regulator, RAM internal regulator, how does it work, and core IC functions, each and everything we have described in our video class. So if you are interested, you can contact on the given number. So now we need to check 112 number pin, and let me show you 112. So here is the 100 and 100, 5, 10, 11, 12. Yes, this pin. Yes, it's going high. So we have, it is available. Actually, you have not to concern. Only thing you have to see to reduce the voltage level. Here we have set it on the 1 volt per division. So that is why you are getting high. 1 volt, 2 volt, 3 volt and 3.3 volt high. The thing you have to check only that the particular signal should not have glitch, and it must be high or low. If it is required to be low, then it must be low, and if it is required to be high, then it must be high. If it is being contrary, like instead of having high it's low, then it's problem. If instead of having low it's high, then it's also having a problem. Then we have to sort out that problem. Now each and everything whatever we have checked is perfectly fine. Now the first two things we have left. Now let's start that. That was telling you before injecting the DC jack, because as soon as you insert the DC jack, you start getting the voltage from this point. Power SRC you get after injecting the DC jack. When you use the DC jack into the motherboard, then you get it. It is saying you that without injecting, you will get this particular voltage. So the process to check this RTC is, the right way to check this RTC signal is to use coin cell. So we need a coin cell. Okay, I am going to inject this CMOS cell into the motherboard. So here is the CMOS cell. Let's insert it. Now the area which it is telling us that RTC VCC. Let's check this supply. Look, why I started from this point, because as long as we have worked, like we have worked on this particular area, the LDO was present, but S5 was not enabled, not having a voltage, proper voltage. It was having 1.2 volt. 5 volt was not present, 3 volt was not present, 15 was not present. That is why I started from this point. However, whenever you begin to diagnose the problem, you should start from the RTC VCC without injecting DC jack. Is that clear? Now let's paste it on this search and find out that generated place. Now here we have got this Schottky diode here. With the help of RTC coin cell as well as with the help of LDO, the RTC cell voltage will be generated. So RTC VCC is not something that, however, it is telling you to check the RTC VCC only. But where you have to check after the diode. So let's check the diode voltage. So it is, I think it is written, it must be written D here. Okay, let's find U6203. U6203. Now it is, I think, here. You can see this tiny. However, somebody has already done. Some job is done on this place. I haven't done anything on this particular place. Now, U6203, this is the two terminal. One is connected with the RTC coin cell, and the other one is connected with the, this one is connected with the RTC cell with the help of 1K resistor, and this is coming from the LDO, okay, from the 3.3 and 5 volt, and both will help to switch this diode, and you will get 3.3 volt on this point, or 3 volt on this point. Now let's check this particular diode. That's what do it has. It has 2.7 volt. So after reducing the diode threshold value, you will get around 2.7 volt, and you are having it. Okay, 2.7 volt. So it's absolutely fine. Now what else is remaining? Let's go back. RTC reset. Now copy it, paste it. RTC reset. Here is somewhere you will find G4201. After the register and after the C2404, you will get a G, a pad. A pad you will get nearby. I hope nearby PCH. Let me check. I haven't seen it. This side. I don't think it is available. This side. So let's find out in this side. I don't think it is available on this side. Let's go back. Now I think I need to remove the heatsink to find out. Let me remove the heatsink from the board. So we have removed the heatsink from the board. It's first generation. Good. Now it is not available. Okay, we are unable to find that G. Okay, the gap or the trackpad we are unable to find. So anyhow, let's find this capacitor or something, the resistor C4 2404. 2404. I think this one. Yes, we have got that C. Now you can see here C2404. We have, I think, this one. Okay. So as it is telling us that with the help of coin cell, we are not using the DC jack into the motherboard. Okay, we are checking it with the help of a coin cell only. Now let's check it. We have 2.76 volt available on this C2404. I think this is the number. Yes, this is what we are checking. So if it is available here, then we cannot have any doubt that it is not going to the, if the board is very fresh, there is no physical damage, so it is definitely going to the PCH. And whatever it is not written here, because we don't have board view, it is really a difficult task to find out that particular register and G mark and the R number and the capacitor. So but we have to do it. Ultimately, the thing which I have already shown you, that was the 32 kilohertz crystal which is available here. Now let's make it sure once again that with the help of only coin cell, do we get that frequency or not. So now let me set my DSO on the auto mode. So now let's check the 32 kilohertz crystal, and we will confirm that whether it is okay or not. So any of the pin you choose. We need to find out the first pin, the input pin. So we don't know which one is the input and output. How can you determine that which is the input and which is the output? So you just keep the probe on any point. Okay, like this point. Let's check this point. Any point. However, the mark is here, but we are checking on this point, and auto it. If you get the less amplitude, and if you have slightly sawtooth form, like there is, you see that there is no good edge, you have no sharp sinusoidal wave, then you can think that this is the input side of the crystal, and this is the output of the crystal. If you have a very, you can say that sinusoidal wave form and very crisp and very crystal and very clear, so this is the output. However, the marking, as you can see, that it is saying you the one number pin. Maybe it could be considered as a input, but in practical, the things are different as in the theory. So the more amplitude you will get on the output. That is why the crystal is used in the board. Now, this is absolutely fine. Again, I could ask you question that what should be the next